Hello everyone, and welcome to the Complete Python Programming course. In this video, we'll talk about errors and exceptions. This video is part of the intermediate level. In Python, you can get two types of errors, or let's call them errors and exceptions, and let's see examples right away. Name equals main. Let's create a loop. Run our application at terminal and see what we can do with that. The first error we will talk about is input equals input, and let's ask the user to enter a file name. Now let's run that and see what we get on the screen. Python 3 main.py. Now notice that indentation error, unexpected indented block. Now this is an error, you cannot catch it, your program will crash, and you need to fix it by fixing your indentation. You will get the same error if you try to do it like this, and also it will produce an error. These errors should be fixed, and they are very different than exceptions. They are syntax errors. You need to fix your syntax. Now this is not our topic is exceptions. Exceptions are errors that you can handle. The error happens and you can handle it in your application. Let's see what we can do about that. Let's create a function and we call it process. Our function will be simple. It will just open a file and we'll take it step by step to see what we can do with that. File name and if equals open and file name. And let's return true. Or let's remove the return statement for now, so we can take it actually step by step. Let's run our function. Result. Trace. Process. And we'll take here the input. And we'll print this. Let's run this code and see what it does. And it's asking us for a file name. In my directory, I created 3 file names. And I have private, public, and I have my program, which is main.py. The difference between public and private is that the private file is now owned by root, which means that I cannot access it. The public file is just a public file. A file without extension is just called public. Now let's see what we can do with that. Enter a file name and we are opening the file in the first step. We run our program and let's enter a file name that doesn't exist. Test. And the first thing we got is trace back and we have an error in the screen. File not found, no such file or directory test. Now this is an avoidable error. Notice what happens here. My program crashed. Now let's take this step by step again and let's go here and let's try with public. When I entered public, my program continued running. This is a main loop. The program should continue running because I don't want to crash it. I need my program to continue. But once I entered something wrong like test, a file that doesn't exist, my entire program crashed because an error was not handled and an exception was not handled, and it propagated all the way to the interpreter to break my whole Python process. Let's take that and fix it. To handle something like that, there's an error generator that will break your interpreter. We use a try except statement. Try and except. A try except statement will try to do this action. If it succeeds, that's fine. If it doesn't, it will just not generate that error that we saw on the screen. And instead, it will just go to except statement and run whatever code we have in there. Let's do this and use return Let's go here, return true, and let's go here, return false. Or let's do a different way. Okay, and an error occurred. Let's try to run that and see what we get in this case. And let's print this and we enter test. Notice that it says an error occurred. Now that's much better than the exception I got in the first case, because now I have an except statement that will handle any error that happens inside the try statement. Well, that's great. My program didn't crash and I can continue using my program without having crashes. But this is very generic error. An error occurred. There is one more thing you can do here. Exception. You catch the exception in your except statement, and as error, you can call this anything you want. You can call it ERR, or E is usually common, and you can return the error itself. Return E. Now in this case, you will get the description of the error. Let's run this program again and test, and we have error number 2, no such file or directory. Now that's great. We have something functioning. Let's try to access private, and it says permission denied. Notice that these errors are descriptive, but they are not something you want to return to your user. It says permission denied. This is not an error you want your user to see. It's a programming error. That's for you, not for the user. In this case, we can handle each error independently and actually use different exception for each error. Let's start step by step and see what we have. Let's remove the try statement and let's try to open our file just without the try statement and test. And my first error, file not found. This is the name of the exception. If you take this, you will be able to work with it. So let's get back to try statement and we catch or we work with that specific exception. Except file not found error. Now that's much better. I am catching a specific exception and return this file does not exist. Let's run this code and see what happens. Run our program and test. And now we have much better error. This file does not exist. This is something you can return to the user. Let's try with private. And my program crashed again because I actually prepared my program for very specific exception, which is file not found if we have the wrong file name. But I didn't prepare my program to handle permission error. That's the second error. I could do something like this. Except you can have as many except statements as you want. In this case, you can use just one generic except statement and you can go with something an error occurred, which will return a generic error in the case of a private. An error occurred, but we want something more specific than that. Notice I have one try, one except that handles the file not found, and I have the last except that handles everything else. And I could nest as many except statements as I need in here. Now let's handle the other error that we talked about. The other error was, its name was permission error. I could handle permission error in here. Permission error. This file is private, so try again. This file is private, try again. So this is much better error message. Now if I run my code, it will return that for private. private, and it says this file is private, try again, and when I try with test, it will say the file does not exist. Notice that this is very compound and it's very good to work with because you can catch specific exceptions. And these things happen very often when we work with databases, when you work with files. You need to catch these exceptions because you don't want your program throwing errors and crashing and breaking. Now my last file is called public. If I use public, it will return OK. Now let's try to write to our file. If write some text, it's an if some text. And let's see what we get when we run this code. And we run our program and public. And we have another error, unsupported operation. Now, the unsupported operation is a little bit of error that I wanted to get actually in this because notice that it has IO unsupported operation. Now, we have two ways of handling this error. Notice that after this point, I have the file already open. And I could go with the try statement here because you can nest your try statements and you can try to write. Otherwise, you can use except statement here and return an error occurred. Now, if we run this code, let's see what happens when we run this code and Python and public. And notice that an error occurred. I don't want to have this error. I would like it to be more specific. There are two ways. You can go here, except, exception, and as E, and you can return the value of E. That's one way of going around it, but I actually don't like to return such errors to my screen. Public, not writable. Notice that the error is just not writable. You don't want, this is for you as a programmer, you don't want to return that, so we can just create our own error and we can return the file is not writable. But we know that the file is writable actually, we opened it in the wrong mode, but I wanted to show this error specifically. This error is called unsupported operation. Let's catch this error and see what we can do with it. The error name is unsupported operation. Now I'm going to run this code with unsupported operation and see what I can get, and I will get a more error. Public, and it says name error unsupported operation is not defined, although the error name is unsupported operation, but notice that has IO before it. Now you need to get the exact error name, so this is IO, and I will run this code again and we will have another error actually. Public, and the error is error, the IO is not defined. This error is a specific, or this exception is a specific to the IO. The IO is not available by default. You have actually to import it. So to fix this, you need to go with the import IO. Now, importing the IO module or package will actually fix this and we will get what we expect. Public, and the file is not writable. Now, this is all great. If we go here and make the file writable, our code should run correctly, and public, and it says OK. Now this second try statement, you actually don't need it here. You can take this exception and add it after other exceptions at the end here, and you can get rid of the entire try statement. And this will run exactly the same. Because what happens in this case, Python will try to open the file, will handle that exception if it happens, and then we'll try them one by one. Now, this way, the try statement will fail and it will take the right exception. That's one thing. This will run exactly the same. You don't need to nest too many try statements. Actually, if you try it, if you are using tries all the time, you might find that your code becomes a little bit different. You wouldn't like it. Imagine that you have a process that has 10 things that could fail. You don't want to nest 10 try statements, and because try it and you will see that your code becomes a little bit strange. This is much better way of handling that, handling each exception by itself. Another thing I want to talk about is we opened our file here, but we didn't close it. Now, we need always to close our file, if close. Now, if no error happens here, it will close by itself, and that will be great because you have the if clause statement. Now, imagine that you couldn't actually write to the file. So an error occurred here. The exception was raised at if write. We never arrived at the if clause, so we opened the file in the case of public. So if we make this file not writable and we run this code now, we will get an error. And let's go and run our code, Python 3 and py, and enter file name with public, and file is not writable. You arrived at this one, but this exception happened at the if write, which means if clause was never executed, and that is a problem. We need to close our files after we work with them. There is a finally statement in Python. Finally comes after the last except, and in the finally statement you could go close the file. Now, if close will close the file after opening it, but there is another thing you need to think about. So you take this out. What happens? The finally statement will actually run no matter what happens here. If all that succeeds, or if you get an exception, the finally statement will run no matter what happens in the try and except. Whether you get exception, whether the whole try succeeds, the finally statement will run. But there is another thing that you have to be aware of, and I never saw somebody demonstrating that in an example. What if you fail to open the file? Now, if you cannot open the file in here, so let's go here and just open this in the, let's go with the writable. And if we have the file that doesn't exist actually, let's remove this without writable. Now let's run this code. So let's go with a wrong file name. If we have the wrong file name, the file wasn't open in this case, and you get the file not found error. And if will not be available because the if variable will be undefined. Let's try that and see how that goes. Let's try with a file that doesn't exist actually. Let's go there and file name X. And notice that unbound local error variable if reference before assignment, because you are trying to close a file, but the file was never open. If does not exist. You can fix that easily by going with if equals none. And in here, if then close the file, and you can just print file closed successfully. Now, if the file wasn't open, it will never run this code, this block of code, because we set it to none. Let's run this and see what we get. Let's go with a file name that doesn't exist, and everything now is fine. It didn't run the if clause statement because the error was here. Now all that works fine for us. Let's try now with the public. Like if we have the public file name, if we run it, like the file closed successfully. That's a great error. We closed our file and everything is fine now. We don't have resources hanging all over the place. That's one thing. Another thing you could use here is an else statement. After the exceptions, we can have an else statement. The else statement will run if the try statement succeeds. Now, let's try that. If we get rid of this one and we close our file in the else statement, if close. Now, the else statement will run only if the if succeeds. If everything was executed in if, you don't have exceptions, you do that in the else statement. And that will work also as you might expect. You have to know about the finally, because you use the finally when you want it to run no matter what happens. You need that else to use it only if the try statement succeeds. In this case, the try statement will not succeed if we try with the wrong file name. So we need also that the if equal none and all that. Use the right one for the right case. The finally and the else can be used in different ways. I don't want to make this lesson too long. Let's talk about the raise statement. There is something called raise, like the raising an exception. The raise goes like this. You go and raise exception. Now here, in this case, I have a return statement. I don't need the return statement. I want to raise this exception. What will that do is return an exception to the caller or propagate it. So let's try this. Let's get rid of that to make the example easier to read. And in this case, file not found, it will do something we call raise. Let me try to run this code and see what happens. And let's go with file X. And file not found, and it will raise. Notice that file not found error, we raised the error. Instead of handling our error, we raised it. Raising it, we sent it here actually. Notice that here we handled the error in the first case, but when we raise it, we let it go. We let it pass by our exceptions. Now, what happens in this case? If you don't handle the raised exception, if you are coming from Java or something that does this all the time, you should be used to that. Otherwise, it might be a little bit strange to you. When you raise an exception, you need to handle it somewhere else. Otherwise, it will keep propagating. Notice that here, when I tried this with a file that doesn't exist, it actually crashed the program. The program is not asking for questions anymore. So let's see how we can handle that. Now, raise here allows you to do the try statement here. Now, this is my try statement in this case, and I need here to handle the exception. And let's try except. This whole process failed, and it raised an exception to my caller, let's call it. And here you can write print and exception was raised by process. Now let's run this code and see what it does when we run it with a file that doesn't exist, like X. Now, if we go to X file, and it will be an exception was raised by process, because this exception was caught in this case. Raise, return the exception. Now, what happened here? Process raised the exception, and we caught it somewhere else. Now, when we try with a file that actually does exist, it will be a different issue. The file is not writable. We continue here. We didn't raise the exception. We handled our exception in this case. We didn't raise it to the rest of the caller of our function in this case. Now, this is a brief introduction to exceptions. We will see them in different examples, and we'll see how we can use them correctly in our code. I didn't want to make this lesson any longer. You can actually subclass exceptions and create your own exceptions and work with that all the way. And we will do that in future lessons. But for now, this is a good introduction. You know how to handle exceptions, and you know what the accept and raise and try and all that. You see them in the code all the time, and that's a very good way to know about them. I hope that's easy. Try to practice that. Try to raise some exceptions. You can try raising exceptions in many ways. You can actually just go with something like this, and you just add here any string, and that would raise an exception. So you can use these to try your code and see what you can do with that. Anyway, if you like this video, support the channel by subscribing. Meanwhile, have a great time and see you soon.